Chapter 1 Introduction to Programming 1 Outline General Introduction to Computer and Programming. The ABC of Programming System Development Life Cycle, SDLC, Feasibility Study, Requirement Analysis, Designing Solution Testing. Design Solution, Implementation, Coding, Unit Testing, Integration, and System Testing. Maintenance. Algorithm Development and Representation. 3.2 1.1 Introduction to Computer Programming. What is computer programming? Computer science versus computer engineering. Computer science focuses on topics in computational theory. These include the virtual aspects of computers, focusing on software, rather than hardware. Closely aligned with mathematics, computer science applies theoretical ideas to solve real-world problems, deals how to build computer systems, and how to solve problems on computers and other electronic technologies using data storage and processing. 1.1 Introduction to Computer Programming. What is computer programming? Computer science versus computer engineering. Computer engineering is somewhere between computer science and electrical engineering. Computer engineering focuses on how to build devices. Combines physics, electrical engineering, and computer science focus on hardware, rather than software. 1.1 Introduction to Computer Programming. Digital image/sound, artificial intelligence, microprogramming, bioinformatics, networks and administration, computer architecture, networks, cryptography, operating systems, computer game development, robotics, computer graphics. 5 Computer science focus solving problem using computer. The disciplines encompassed by a computer science degree are incredibly vast: simulation and modeling, software system analysis, computer programming, software development, software systems, data management, web development, design, databases, database administrator, parallel programming, iOS development, mobile development. What is computer programming? 6 Computer programming. It is a way of giving computers instructions about what they should do next. The process of designing and building an executable computer program to accomplish a specific computing result. These instructions are known as code, and computer programmers write code to solve problems or perform a task. Programming involves tasks such as analysis, generating algorithms, profiling algorithms, accuracy and resource consumption. The ABC of programming. Before you learn how to read and write the C++ language itself, you need to become familiar with some key concepts in computer programming. They will be covered in 3 sections. A. What is a script and how do I create one? B. How do computers fit the world around them? C. How do I write a code for to solve problem? Once you have learned the basics, the following chapters will show you how the programming language, specifically C++ in this course, can be used to tell computer how and what you want them to do. 7. The A of programming. 8 What is a program or code? A program is a series of instructions that a computer can follow to achieve a goal. You could compare program to any of the following recipes by following the instructions in a recipe, one by one in the order set out. Cooks can create a dish they have never made before. Handbooks. Large companies often provide handbooks for new employees that contain procedures to follow in certain situations. Manuals. Mechanics often refer to car repair manuals when servicing models they are not familiar with. These manuals contain a series of tests to check the key functions of the car are working, along with details of how to fix any issues that arise. Similarly, program can allow the computer to check the current situation and only perform a set of steps if that action is appropriate. H. The A of programming. How do I create one? Writing a program. You need to first state your goal, i.e. the problem and how you solve it, then list the tasks that need to be completed in order to achieve the goal. Humans can achieve complex goals without thinking about them too much. For example, drive a car, cook breakfast, or send an email without a set of detailed instructions unless it is a new task. Likewise, programs are just a series of short instructions, each of which is performed in order to solve the problem in hand using computers. However, that a computer doesn't learn how to perform tasks like human, it needs to follow instructions every time it performs the task. So a program must give the computer enough detail to perform the task as if every time were its first time. 9. The A of programming. How do I create one? Writing a script. Start with the big picture of what you want to achieve, and break that down into smaller steps. 1. Define the goal first. You need to define the task you want to achieve. You can think of this as a puzzle for the computer to solve. 2. Design the program. To design a script, you split the goal out into a series of tasks that are going to be involved in solving this puzzle. This can be represented using a flowchart. You can then write down individual steps that the computer needs to perform in order to complete each individual task. 3. Code each step. Each of the steps needs to be written in a programming language that the computer understands. In our case, C++. 10. The A of programming. 11. How do I create one? Writing a script. Design the program. Once you know the goal of your program, you can work out the individual tasks needed to archive. This high-level view of the tasks can be represented using a flowchart. The A of programming. How do I create one? Writing a script. Design the program. Each individual tasks may be broken down into a sequence of steps. When you are ready to code the program, these steps can then be translated into individual line of code. 12. The A of programming. Code each step. Each steps for every task shown in a flowchart needs to be written in a language that the computer can understand and follow. In the subsequent chapters, we are focusing on the C++ language and how it is used in software development. Just like learning any new language, you need to get to grips with the vocabulary, the words that computers understand, syntax, how you put those words together to create instructions computers can follow along with learning the language itself. You will also need to learn how a computer achieves different types of goals using a programmatic approach to problem solving. Note the focus of the course will be on coding using C++. 13. The B of programming. How do computers fit the world around them? Computers create models of the world using data. For example, here is a model of a hotel, along with some model trees, model people, and model cars. To a human, it is clear what kind of real-world object each one represents. 14. The B of programming. How do computers fit the world around them? A computer has no predefined concept of what a hotel or car is. It does not know what they are used for. It will not know what star rating your hotel is. So how do we use computers to create hotel booking apps, or video games where players can race a car? The answer is that programmers create a very different kind of model, especially for computers. Programmers make these models using data. The data is all the computer needs in order to follow the instructions you give it to carry out its tasks in the script/program. 15. The B of programming. Objects and properties. Objects, things. In computer programming, Each physical thing in the world can be represented as an object. There are two different types of objects here, a hotel and a car. Each object can have its own properties, events, methods. Together they create a working model of that object. Properties, characteristics. All cars have a make, a color, and engine size. You could even determine their current speed. Programmers call these characteristics the properties of an object. Each property has a name and a value, and each of these name/value pairs tells you something about each individual instance of the object. 16. The B of programming objects. Events in the real world. People interact with objects. These interactions can change the values of the properties in these objects. An event is the computer's way of creating interaction, like saying, "Hey, this just happened." What does an event do? Programmers choose which events they respond to. When a specific event happens, program often uses different events to trigger different types of functionality. So a program will state which events the programmer wants to respond to, and what part of the program should be run when each of those events occur. 17. The B of programming objects. Methods represent things people need to do with objects. They can retrieve or update the values of an object's properties. What is a method? Methods typically represent how people, or other things, interact with an object in the real world. They are like questions and instructions that tell you something about that object, using information stored in its properties. Change the value of one or more of that object's properties. What does a method do? The code for a method can contain lots of instructions that together represent one task. When you use a method, you do not always need to know how it achieves its task. You just need to know how to ask the question and how to interpret any answers it gives you. 18. The B of programming. 19. Objects. Methods. The B of programming. 20. Putting it all together. The C of programming. 21. How do I write a program for creating computer applications? C++ will be used in this course. The C of programming. Most important basic elements for programming languages are programming environment, data types, variables, keywords, logical and arithmetical operators, if-else conditions, loops, numbers, characters and arrays, functions, input and output operations. 22. 1.6 System SD Development Life Cycle, SDLC, Systems Development Life Cycle, SDLC, a structured step-by-step approach for developing information systems. Typical activities include determining budgets, gathering business requirements, designing models, writing user documentation. Software Development Life Cycle model. The steps, phases, to follow when building software. A theoretical description of what should be done. Life cycle, the actual steps performed on a specific product. Software Development Life Cycle. Feasibility study. Define at system to be defined. Define the project scope. Prepare the project plan. Planning. Develop. Help desk. Fix software error and bug support. System change. Maintenance. Gather business requirement. Prepare software project management plan. Analysis. Design. Implementation. Software installation. Prepare user documentation / user training. Develop software architecture. Develop system model. Development. Testing. Build technical architecture. Build database and code. Write test case. Perform different testing case. 25. Software Development Life Cycle. Phase 1. Planning. Planning phase involves determining a solid plan for developing your information system. 3 primary planning activities. 1. Define the system to be developed. Critical success factor, CSF, a factor simply critical to your organization's success. 2. Phase 1. Planning. Set the project scope. Project scope clearly defines the high-level system requirements. Scope creep occurs when the scope of the project increases. Feature creep occurs when developers add extra features that were not part of the initial requirements. Project scope. Document a written definition of the project scope and is usually no longer than a paragraph. 3. Phase 1. Planning. Develop the project plan including tasks, resources, and time frames. Project plan defines the what, when, and who questions of system development. Project manager, an individual who is an expert in project planning and management, defines and develops the project plan and tracks the plan to ensure all key project milestones are completed on time. Project milestones represent key dates for which you need a certain group of activities performed. Phase 2. Analysis. Analysis phase involves end users and IT specialists working together to gather, understand, and document the business requirements for the proposed system. 2. Primary analysis activities. 1. Gather the business requirements. Business requirements. The detailed set of knowledge worker requests that the system must meet in order to be successful. Joint application development, JAD. Knowledge workers and IT specialists meet, sometimes for several days, to define or review the business requirements for the system. 2. Phase 2. Analysis. Prioritize the requirements. Requirements definition document prioritizes the business requirements and places them in a formal comprehensive document. Phase 3. Design. Design phase. Build a technical blueprint of how the proposed system will work. 2. Primary design activities. 1. Design the technical architecture. Technical architecture defines the hardware, software, and telecommunications equipment required to run the system. 2. Phase 3. Design. Design system models. Modeling the activity of drawing a graphical representation of a design. Class diagram. Model activity diagram. Model sequence diagram. Graphical user interface, GUI. The interface to an information system. Graphical designer and computer front-end developer. GUI. Screen design. The ability to model the information system screens for an entire system. Phase 4. Development. Development phase. Take all of your detailed design documents from the design phase and transform them into an actual system. 2. Primary development activities. 1. Build the technical architecture. 2. Build the database and programs. Both of these activities are mostly performed by IT specialists. Phase 5. Testing. Testing phase verifies that the system works and meets all of the business requirements defined in the analysis phase. 2. Primary testing activities. 1. Write the test conditions. Test conditions. The detailed steps the system must perform along with the expected results of each step. 2. Phase 5. Testing. Perform the testing of the system. Unit testing. Tests individual units of code. System testing verifies that the units of code function correctly when integrated. Integration testing verifies that separate systems work together. User acceptance testing, UAT, determines if the system satisfies the business requirements. Phase 6. Implementation. Implementation phase. Distribute the system to all of the knowledge workers and they begin using the system to perform their everyday jobs. 2. Primary implementation activities. 1. Write detailed user documentation. User documentation highlights how to use the system. 2. Provide training for the system. Users. Online training runs over the internet or off a CD-ROM. Workshop training is held in a classroom environment and led by an instructor. Phase 6. Implementation. Choose the right implementation method. Parallel implementation. Use both the old and new system simultaneously. Plunge implementation. Discard the old system completely and use the new pilot implementation. Start with small groups of people on the new system and gradually add more users. Phased implementation. Implement the new system in phases. Phase 7. Maintenance. Maintenance phase. Monitor and support the new system to ensure it continues to meet the business goals. 2. Primary maintenance activities. 1. Build a help desk to support the system users. Help desk, a group of people who responds to knowledge workers' questions. 2. Provide an environment to support system changes and fix system error and bugs. 1.3 Algorithm development and representation. Problem solving, algorithm designing, and modeling logic all are ways of preparing step-by-step instruction that a programmer prepare to instruct the computer. The way they depict the instruction varies. Structured programming, a design which focuses on process. Follows top-down approach. Programs are divided into small self-contained functions. Provides less reusability, more function dependency, less abstraction and less flexibility. 40. 1.3 Algorithm development and representation. Procedural programming can be defined as a programming model which is derived from structured programming. It is based upon the concept of calling procedure. Procedures, also known as routines, subroutines, or functions. During a program's execution, any given procedure might be called at any point, including by other procedures or itself. Example: Fortran, COBOL, BASIC, Pascal and C++. Object-oriented programming, a design which focuses on data. It follows bottom-up approach. Programs are divided into small entities called objects. Provides more reusability, less function dependency, more abstraction and more flexibility. Example: Java, C++, C#, Python, PHP, JavaScript, Ruby, Perl. 41. 1.3 Problem solving, algorithm designing, and modeling logic. Problem solving, basic process for developing a solution to a problem. There is an existing problem. For this problem you looking solution. Problem solving sets the stage for a process that we will use to develop solutions to the problems. In our hand, the basic process is important because it can be used to solve a wide variety of problems, including ones where the solution will be written in some other programming language. It needs clarity, understanding, possible solution, conclusion, and decision, action. 42. 1.3 Problem solving, algorithm designing, and modeling logic. Algorithm design. Every problem solution starts with a plan. That plan is called an algorithm. A procedure is a finite sequence of well-defined instructions, each of which can be mechanically carried out in a finite amount of time. An algorithmous procedure consisting of a finite set of unambiguous rules, instructions, which specify a finite sequence of operations that provides the solution to a problem. In other words, an algorithm is a step-by-step procedure to solve a given problem. 43. Algorithm design. Most algorithm development process consists of 5 major steps. Step 1. Obtain a description of the problem. Step 2. Analyze the problem. Step 3. Develop a high-level algorithm. Step 4. Refine the algorithm by adding more detail. Step 5. Review the algorithm. 44.